said what value should it be. I just didn't answer this question.
Oh, that's great. Like he found the prescaler, he didn't get the value. But did you get full points for this one?
Yeah.
What was yours?
So the first problem, basic for loops, it's gonna increment it by 2, right? So 5, it's gonna be 5, 7, 9, 11, right? Whenever it's adding 11, it's still going to get into this and do the summation. That's why you have to count 11 into it. But after 11 becomes 13. So right after that, it's gonna increment itself by 2. So next time it reaches this condition checking, it won't pass. So it won't get into it anymore. However, the final value for I, if I use if that's the same problem in the final exam, but I'm asking what's the final number for I? What is it?
Oh, front of all these I?
Yeah.
13.
Yeah, it's gonna be 13, right? Even though it's not getting to the loop to get a new sum, but I will be updated after this. So in that case, what is sum for this problem? 12, 9, 11, that's 21, that's 32, right? So next, this one, 1 second to give you a 0. So before that 1 second pulse is always 1. So it's gonna stay here for a long time. So the way the microcontroller can will know that it is 1 is because it's taking this instruction from the instruction memory and checking it. So it's being executed actually. So for the majority of the time, this line is being executed for the most of the time. And whenever it stays here, we'll keep checking this one for a long time as well. Not long, but 30 milliseconds. But compared to other ones, but do you know the scale of the time it executes? What was the question first?
So wait, if it's the majority of the time it's at logic 1, why wouldn't it be stuck at line 3 most of the time? Because if it's at logic 1, then it won't be stuck on line 1, it'd be stuck on line 3.
Because this one is just a very short pulse.
Yeah, so most of the time it's at logic 1. If it's at logic 1, it would be stuck on line 3.
Line
Line
1.
Oh,
Line
wait,
1.
sorry, I'm.
Yeah.
Oh.
That's all right. That's all right. Yeah.
Oh,
So it's gonna be 1, 3, definitely, right? Not 3, 1. And then the rest are pretty much the same, so it's okay for the orders, I think.
One count because they're just constant time operations.
Which one?
They're all one count because they're constant
Yeah,
time operations.
yeah, I think so. So the order here doesn't really matter. I graded this problem really leniently, so I didn't take points off for here at all. This guy, one to a prescaler timer 1. What's the frequency for timer 1 usually? 16 megahertz, right? 16 megahertz divided by 6 divided by 8. That's the real frequency is doing the counts. Times what? 10 milliseconds over 1,000 to convert to seconds. And that's the correct expression to use to get the answer, right?
Yes.
So the compare mode, keep in mind. I talk about this in class for several times, but people are still losing points, probably because you didn't attend the class or something. And I posted that lecture on the website. It's a different PLN mode, right? Don't get confused with the PR2 stuff. This is just a match problem. You see, it's trying to match. No, it's trying to overflow it, right? Overflow it. So what's the total counts?
40,000.
It's compare mode. What value in here will set this one to this long, right? So 1 millisecond divided by 1,000, so get a convert to seconds, and times the time. So you want to time the frequency, which is 16 mega over 4, right? That's it. Done. Sometimes you are still confused at. I know this is new anymore, but still. Over like 70 to 80% of you guys are still getting one of these problems wrong. I mean, if you got this wrong or this wrong, I don't blame you, because this could be relatively more confusing. It's because it's involving that 10-bit, 8-bit timer 2 stuff. But for these ones, I was really, I was even trying to scare you to give you a quiz on that day, right? So it's really a very fundamental problem. Shouldn't get any points in here in the future. So remember, if you're given with a time, right? So something time, it's a seconds, right? You want to times that frequency, because that frequency is mega counts per second, so you can get a time cancel. That's how you can get the counts, right? So,
What was the final value for number 3?
is that 4,000?
Oh no, for
Oh,
number
so
3.
is this one?
Yeah.
Oh, starting value, sorry. Yeah. Right? Starting value.
Okay.
Remember the timer 1 right timer function? You have a 0x1 0 0 0 0 minus that counts, right?
Yeah.
So it's asking for a starting value should be this, because the counter starts counting from here, right? Counting. And here's your desired counts. Here's the starting value. Okay? So it's asking for the starting value, right? So it should be 2 to the 16th minus this. What about this one? Still compare mode, compare mode. Compare to reach where? Because from here as a start to this as the end, you have 0x00ff minus 0x 000f, this many counts. And you should know that this is 255 and this is 15, right? So eventually this becomes what? 240. And so given with the counts, number of counts, and to calculate the time,
Divide by counts per second.
still the same problem. So 240 what? Divided by 16 mega divided by 16, which is the prescaler. All right? That's it. And it's asking for, just let you know, okay? It's a present for the full break, coming full break anyway. So it's asking for milliseconds. If you are doing like 64 microseconds, I'm not taking points off. All right? I didn't take points off if you are doing microseconds. But in the future, it should be, if I'm specifying that, it should be in milliseconds with 2 significant digits. You just have to do it that way, right? So this becomes 0.068 milliseconds, I think. That's the answer.
That's the answer for problem 6.
Oh. 0.24 milliseconds
There we go.
after grading 100 exams. You know it?
Yeah.
All right. This one. I just figured out you guys don't read it. Oh, this one, right? It's asking for PR2 value and the prescaler. Like 80% of you guys only answer the first question. Rushing. Let's see this one first. Still compare mode. Compared to the value in CCPR1, it's setting CCPR1 this much ahead of timer 0. So this will be the number of counts you have to deal with. So given with the count to find out the time, still the same problem. 0x 0110 do what? This is the number of counts, right? Divided by what? 16 mega over 4. That's it. Keep in mind that you want to convert it to milliseconds. Again, 2 significant digits. Keep that in mind. All right. The next, timer 2 prescaler, which one to use? Remember 1 to 1 is giving you what? 256 over
16 mega.
wait,
Yeah.
16 mega? Yeah, that's for PR2, right? So that's what? 16 microseconds. 1 over 4 is 256. Why 256, not 255?
Because it's the period.
It's a PR2 plus 1. Alright? So it's 256 counts. Even though PR2 registers only 8 bits, the maximum number seems to be 255. So adding 1 will define the period. So I have to use 256 on the top. So 256 divided by 16 mega will give you, with 1-to-1 prescaler, it's giving you this much as the longest period you can have. For 1 over 4 prescaler, you're having 16 mega divided by 4, and which is 64 microseconds. And with 1 to 16, it's 256 divided by 16 megahertz divided by 16. And it's giving you 256 microseconds. So it's requiring 120 microseconds. So you want to pick up the one that can handle it. So these two cannot, because the maximum is already less than whatever is required. So I have to use this one. So now it comes down to the case that it's already answered the first question. It should be 1 to 16, right? And now the second question is, what's the PR2 value I'm put in the register to make that happen? So just list the equation here. It's PR2 plus 1 over what? Over 16 mega divided by 256 divided by 16, right? The prescaler, and that becomes 120 microseconds, right? And you want to divide that by 10 to the 6 to convert it to time, to seconds. Okay? Right?
Mm-hmm.
So eventually it's giving you 119. I think probably only less than 10 students made it right eventually. Less than 10. It's either 120 here or something else. For this one, duty value. Duty value is the value that counts. It's not a percentage or not a time. This counts. This counts. So this is the counts being put in where? Remember, I did this several times.
What did I just do with my calculator wrong? 'Cause you crossed out my 4.
So next time in the final exam, I'm gonna draw 4 boxes that let you fill in.
Yes, that's what I see.
All right,
He crossed out my 4.
let's do it. What is here?
I just put in my calculator wrong.
What is this?
PR2.
No. Oh yes. You're better than me. What is this? Proud of you. So my La Plata County boy. What is this? CCPR 1H. CCPR 1L. What is this? DCXB or DC1B, right?
Yep.
All right.
So
If I draw one more here, what is that? It's nothing, just 2 bits. So if I draw 2 arrows here and draw 2 boxes here, it's gonna be on the final exam. I assure you guys.
FLSC over 3.
All right. What are these?
FOC.
What is this?
FOC over 4.
Okay.
I'm confused what I did wrong because you crossed out something.
Clear? So now let's take a look at this. This problem.
Wait, what did you do?
Duty value is 96. Where 96 is being stored in? Here. Starting from here, right? So it's gonna be a 96, it's a 10-bit data, but 96 decimal value in here.
Yeah, that's FOC.
And so how long it takes to finish the counts? You can look at this point, the LSB is being flipped at this frequency, which is 64 megahertz. So this becomes 96 over 64 megahertz. Over the prescaler is what? Is 16, right? That's the time. That's the time.
Yep.
Which is, this is what? This is this.
24 micro.
This is this time, right? This guy. Exactly.
Yep.
No, pre-16.
Okay? this guy is this guy. What is the period? It's right given. You don't even need to calculate it.
16N.
Divided by 128 microsecond, right? We got a percentage here, which is like 18.75.
Yep.
So I think I did
All right. If I change the problem a little bit in the final exam, for example, these are all the same without any changes.
64 to 16.
I'm asking if I need a 10% duty cycle, what the duty value should be,
Just reverse them out.
right? So that will be 10%. It's going to be 12.8 microseconds, right? Equals the duty value over 64 mega over 16. That's it. Okay. Any questions on this? Just seal this in your mind. This one. Seal in your mind. Okay, now let's see this one. Look at this one. That's the decimal number. If you convert AB into 0x0, 1, 0, 1, 0, and 1, 0, 1, 1, right?
0B.
It's AB, right? It's AB.
But you said 0x and then did a binary number, 0B, to show that it's a binary number.
I'm not getting that. What's that?
That's you have a binary number there, but you prefaced it with 0x.
It's not a binary number.
No, you just turn AB into a binary number.
Oh, yeah, yeah.
So B.
Thanks. Yeah, sorry, yeah.
Oh.
So you convert this one. You can use the calculator to calculate it. This is what? 2 to the 7th, right? Yeah. So convert this number to a decimal number. You'll find out it's 171. So this has to be decimal. It's gonna be signed because it's a positive number, or you do a person B or person U. Either one, it's gonna work. It's gonna be OR logic, right? OR logic. So this one is 30, and it shows a 0. This is actually a character. So if you look at the appendix over here for 0, right? It's 0x30. That's why this guy needs to be person C. And for the rest, 2, they are both hex numbers, should be person X. And the C compiler we use doesn't recognize person H. But I didn't take points off if you do a person H. Okay, it's okay. So the next one is also person X in here. And for this one, you need while button pin get value is 0. Don't do anything, right? Because it's holding. And whenever someone presses it, it gets out from this loop. It's going to do the same, but equals 1, right? So whenever you press it, this is the wait. This is press. And wait. And we'll release it and move to the next, right? Move to the next. So after it gets out from the loop, the first thing you want to do is toggle it, because it's asking to toggle it. It's just do something, right? It's asking you to do the LED toggle. Toggle. So after you toggle it, you need to set up a timer. So it's going to be timer 1. Write. Oh, timer. Will determine how long it is. But after this one is written, you want to start the timer by putting this one to 0, right? Clear it. So it's ready to count. right? That's it.
So you just want to toggle it one time in the ISR.
Yeah, just toggle one time.
Times per buffer
Oh,
crash.
it's gonna toggle always toggle because it's gonna come back to the ISR later, right? There's no flag here, so it's always interrupting. So this one, how long it is? It's asking you to do a, how long?
10 milliseconds away.
Oh, 10 milliseconds, right? So 10 milliseconds to a calculation. I didn't take points off, you are not making this exactly right. I was super generous on grading this one. So 10 milliseconds divided by 1,000, converting to seconds. Convert to seconds times what? Times timer 1 is going to be 16 megahertz divided by the prescaler, which is 8. And then it's giving you a number here, right? So you want to use 0x10000 minus whatever here to make it happen. So the bottom line is you have to put this function over there. You have to clear the flag. If you have these two there, I'm not taking points off. If you are missing one of them, I'm taking like either 1 or 2 points off. All right, happy Friday.
Happy Friday.
Not necessarily. You're gonna lose so many other points, other problems. But hopefully you can get better in the final. Any other questions for this exam? Good. All right. Let's talk about the lab 6 and lab 7. We still have time. Only 9 minutes left. Gonna do it really quick. Pick. RC1. BJT. IR LED. Send the light signal to the decoder. GND. VCC. And what is this?
RC0.
Send to where? RC0. Is it being used? No, it's not used. Why do we still send it to here?
It's a GPIO.
It's probably for some other purposes, I don't know. It's not being used. So I have to connect a jumper wire to where? RB7. Why? Because RB7 is part of what? UR2. What is this module? USART 2. And RB7 is what? RX. What? 2. Is that clear?
Yep.
Okay, so let me ask one question here. If I'm just sending one character, this one is going to work so hard to create that PWM, right?
Mm-hmm.
And it's out. This one will send that light. So the light is going to happen. And it's in the air, right? It's in the air. Is it stoppable?
Then no.
So,
Me and Kobe spent a little too long staring at the eye.
is it stoppable? No. It's going to arrive where? It's going to reach the decoder, right?
Yeah.
Is the decoder powered up? Grounded? Yes. It's active. Not stoppable. Reaches it. What's going to happen? Signal, right?
Mm-hmm.
Okay. No matter how the connections are, is it stoppable?
No.
Once you kick it out, not stoppable. Signal is going to come here. Digital signal, right? Why it's not a PWM signal?
Because it's decoding.
The decoder decoded it, right? So this comes in with a certain protocol, being controlled by what? What's the protocol is being controlled? Let's say the baud rate. What's the baud rate is being controlled? So I know that this is 2 bits, this is 3 bits, this is 2 bits, instead of like 1, 2, 3, right? I know this is a certain number of bits with a certain frequency. This is controlled by a baud rate. Does it have to be 9600?
Can't.
Does it have to be 9600?
No.
Okay, it doesn't have to be 9600, right? Okay, and this one you have to use a jump wire, the jumping wire or a jumper connect to RX2. So if this is not stoppable it's gonna toggle this line. It's gonna toggle this line by this signal, right? Just a metal wire. So which means data streams in. So I have to make UR2 ready. Is it ready? Why is always ready?
Programmed it.
Because you set it up that way.
Since you did the MCC, right, you do all the things and it's ready to run. It's powered up and grounded inside the chip, so it's ready. Whenever data comes in, how it knows data comes in? You took a coffee before you press that button, right? So why it's not happening earlier?
Because it pulled down.
Yeah, it pulls down. By what?
It baud rate, so it pulls it down for exactly 1 bit, and then after that it starts the message.
So before it pulls down, what happened in the
Oh, it's
previous
keeping
line?
it. There's no pulses at all. So
It's just a constant 1, right?
Yep.
So this guy is receiving a constant 1 previously. Once this getting put down to 0, it starts sending the data. So it knows this data starts being sent, and so it should start receiving the data, right? That's called protocol. Super simple protocol, right? It's UART protocol. And stopping with the 1 bit, so that's stop bit. That's a starting bit or start bit, right? So you send a which signal in the PWM will give you a voltage 0, will give you a 0.
High.
So pulses, right? Pulses will result in a 0. And 0 will result in a 1. That's how the decoder works, right? So in that case, when you are writing that signal sending for 1 bit, what you want to do is the following code snippet here. This one, super classic. Take a look. Why does this make sense? LED on is IR LED, right? What is being written in there? 255?
No.
1?
I think it was like 30.
Why 30? What is 30?
38
It's just. It's the
What is
duty.
it? Look at the function. What is the function? PWM, load, duty value. So what is in here? The duty value.
We defined it.
You put a duty value in there, it starts sending that PWM form, right? Waveform. And giving you a what as the output of the decoder.
1 or 0.
Why 0?
Because
It's a start bit of the UART. It pulls it down to start UART communication. What's next? After it turns it on, is it auto control? Can you control it? After it turns it on, it's gonna be always doing the PWM, right? It's gonna be on. Is that stoppable?
yeah.
No, by far no. The light's in the air already.
Oh.
What's gonna happen? So you wanna do what? You wanna control it. How to control it? Set up a timer 1 immediately.
Right into the timer.
Okay? So the timer, set up a timer, the timer starts counting, right? Then you clear the flag, so it's gonna wait until it's turns on, the flag turns on. So now let's start waiting here, so let the timer run, okay? What is missing?
LED off.
Why? You wanna control it.
Yeah, you want to stop it from sending it.
If you don't do an LED off, what's gonna happen?
It's just going to receive a bunch of zeros.
It's always oscillating, right? You're always getting air in the light in the air. So now let's see the send. That's a major code you can use in your Lab 6. Okay, super critical. Let's see if that makes sense. So treat this code snippet as one group, one entity. So now it's just turning it on, set a timer. Easy. Okay? Now let's see. What is this? The easy thing, right? We just went through. What is this sending? A 0. Sending a 0, a starting bit. Did it turn it off? Does it turn it off? No, it doesn't have to turn it off. Why? You are not done yet. The character has 8 bits. So the starting bit, pull it down, they have other data to be sent. So now let's move to the next. This one, what's happening? You have a mask, and you are shifting the mask to end that bit by bit to the left. So you are extracting every single bit from the data. Keep in mind, this is given, this is easy, okay? This is just one group of code. And take out the data, send it, and wait, and then do a stopping bit. It's still the same type of code, and then eventually what? Eventually turn it off here. So turn it off, the stop bit will be 1, right? Okay? So that's the basic send code will be used in the Lab 6. So we'll cover more on Monday as well, okay? Just let you guys know. So the Lab 6 code template is already provided on the website. It's at the bottom, scroll down to the very bottom of the Lab 6 instruction. It's there.
Dr. Lee,
What's that?
a lot of